So we've already touched on this topic, we just didn't call it anything, but the remainder theorem tells us a lot about those rogue polynomials that we try to graph. So here's another one of those rogue polynomials. 3x squared plus 8x minus 4. Hopefully by now, as soon as you see this, you see, oh, it's squared, therefore it is a parabola. And we know the parabola could have as many as 2 roots when it crosses the x-axis. So the whole job of Common Core of Algebra 2 is to find those roots and then to find out how the parabola behaves between those 2 roots. So we taught you how to divide. So the first thing we're going to do over here, is take this polynomial and divide it by x minus 2. And since most of you like the reverse table, I'm going to do that. So this is 3x squared. And we know that means this has to be 3x. That's negative 6x. Okay, I've got to get a positive 8x. So that means this has to be 14x for those to add together to get 8x. So this is 14. That's negative 28. That does not equal negative 4, so there's a remainder. Shocking! So what would the number here have to be? 24. A 24 and a negative 28 gives me that remainder of negative, gives me that negative 4. So if I were to write this, if I would say 3x squared plus 8x minus 4 divided by x minus 2, my answer is 3x plus 14 plus a remainder of 24 over x minus 2. Okay, what was the next thing I have over here? Whoops, make that a eraser. You want me to put 2 into that problem. So when I put a 2 into this function, it is 3 times 2 squared plus 8 times 2 minus 4. That's 4, that's 12, that's 16. 12 plus 16 is 28. 28 minus 4 is 24. Interesting. Let's try that again. I've got a cubic here, so I know it goes one tail down, then one tail up, because it's raised to the 3rd power and the leading coefficient is positive. I'm going to divide by x minus 3. And now I'm going to do this one by long division, since you're going to be required to understand both. X cubed, I have to be careful here. There is no x squared plus 2x minus 3. Okay, that's going to be x squared. X squared times x is x cubed minus 3x squared. Now we know the drill. The drill is add the opposite. 3x squared plus 2x. Okay, x times what gets me 3x squared plus 3x. Okay, now we do add the opposite because we're subtracting, and this is the easy way to subtract. 11x, bring down the minus 3. X goes in there plus 11 times, giving me 11x minus 33. Once again, we're going to add the opposite. And when we do this, we get 30. Anybody want to take a guess what the answer is when we put 3 into here? All right, so when we take 3 and put it into the polynomial h, 3 cubed is 27. 27 plus 6 minus 3, that's 33 minus 3 is 30. Wow. So I think you can see where I'm going with this. You see, remember the horrible horizontal child? Well, in order for this to equal 0, x would have to be 3. And here, x would have to be 2 in order to get 0. So when we were dividing, the remainder was telling us whether the number that we were dividing by was a root or not. And furthermore, it told us where we were on the parabola. So for instance here, we don't know what the root is to this parabola, but we do know that when we put 2 in, we got 24 as a remainder. So that means 2 results in the answer of 24. It could be there, or it could be there. We definitely know 2 is not a root, because in order to be a root, you have to have a remainder of 0. Likewise, right here with this parabola, we had a positive remainder. So therefore, 3 is not a root. It does indicate that the cubic, sorry if I called it a parabola before, it does tell us that the cubic function, when I put a 3 in it, is in the positive zone somewhere. All right, so we have a polynomial here, and if we look at it closely, we go through all our training. It's a cubic, so that means one tail down, one tail up. But when I go to see if my degrees are decreasing in order, I notice that the coefficient here is unknown. It's k. So right now I got to stop and look at this polynomial and go, whoa, what do they really want me to do with it? Find a value for k so that x plus 1 is a factor of p. All right, so if it's a factor, this is fancy for it's a root. And another word for root is a 0. So we want it that we put negative 1 in here. It's a root. And remember, the reason why we're looking for negative 1 is because we do the opposite. Remember the horrible horizontal child? X plus 1 has to equal 0 because on the x-axis, all points have 0 as their y value. So that means x is a negative 1. So that is actually the number I'm putting into the equation. I'm not putting in plus 1. I'm putting in negative 1. So if I were to put negative 1 in, the polynomial when I put negative 1 in is negative 1 cubed plus k negative 1 squared plus negative 1 plus 6. Now I'm going to change one more thing here. I want this to be 0. That when I put this negative 1 in here, it results in an answer of 0 because that makes it a root. So now the math beyond that is very simple. Negative 1 cubed, let me just go down here. Negative 1 cubed is negative 1. Negative 1 squared is 1, so that's going to be k. Negative 1 plus 6, and I want that to equal 0. Negative 1 plus negative 1 is negative 2. Negative 2 plus 6 is 4. So k has to be negative 4. Find two factors of p for the value of k found in part A. Huh? All right, so here's the key word. Other two factors. That means that this is factorable. So I'm going to clean this page up. And so far, I'm going to concentrate on what I have here. I know that x cubed minus 4x squared, right? Because we just found k to be minus 4 plus x plus 6 is factorable. And guess what? We know one of the factors, x plus 1. So now x plus something times x plus another something. That's what they're asking us to find. Find the other two factors of p. So you can look at this and you can see factor by grouping, because there's 4 things here, but that's not going to work. So this is what I'm going to do. I'm going to divide by x plus 1. You guys like the table? So I'm going to do the table. x1, it's got to be x cubed, so that's x squared. Now we have to be negative 4x squared, so this has to be negative 5x squared to cancel out, so that's a negative 5x. It has to be a positive x, so this has to be a 6x. And there's 1. Do you see now why I divided by x plus 1? Because what would be left is a lovely quadratic. A quadratic is made up of 2 binomial factors. And that quadratic that's left is x squared minus 5x plus 6. And then when I factor that, that becomes x minus 3, x minus 2, and x plus 1. Those are the 3 factors, and there are 3 factors because it's raised to the 3rd power, of this polynomial p of x. So this kind of answers the question, if you can't do factor by grouping, what else can you do to see if it factors? So we're leading up to, and I'm going to pull up Desmos for a second. There it is, graphed on Desmos. And so if you can't factor something, one of the first things you're going to do is to graph it and see if the roots are very easy to find. And in this case, it was. Negative 1, 2, and 3 were our roots. That's why if I write my roots in factors, 2 comes from x minus 2, 3 comes from x minus 3, and negative 1 comes from x plus 1. All right, last example here. This is how we want you to think of all polynomials. Once again, hopefully you've drilled into your head. Before you do anything with this polynomial, the first thing you do is get a picture of it. It's to the 4th power. And since it's a positive, we know one tail up and the other tail is up. And then we learned from our worksheet the other day that if it's to the 4th power, there are 3 minimums and maximums. So 1, 2, 3. 2 minimums and a maximum. Is 1 a zero of this polynomial? Well, now you have many weapons to figure out if 1 is a root. We can do the obvious. We can go to Desmos and we can graph it. So you can write down the ways to figure this one out. 1, we could graph it. We can divide by x minus 1. Or we can simply put 1 into the polynomial and it better equals 0. These are the three easiest ways to figure out if 1 is a 0. Well, for the most part, you guys are going to look to graph it because that's easy. I know very few of you are actually going to take the time to do x minus 1 into x to the 4th plus 3x cubed minus 28x squared minus 36x plus 144. Heck, I wouldn't even do that. But honestly, I wouldn't graph it. This is the method I choose. I choose, sound like that stupid cartoon, Peekaboo, Power, I choose, or Pikachu, or whatever the heck cartoon it was, the remainder theorem. If the remainder is 0, it must be a root. So that's what I'm going to do. I'm simply going to put 1 in there. Okay, 1 to the 4th minus 3 times 1 to the 3rd minus 28 times 1 squared minus 36 times 1 plus 144. 1 to the 4th is 1. 1 to the 3rd is 3 minus 28 minus 36 plus 144. I kind of think you can see by right now that 1 is not a root. This is where we want you to be powerful in your estimating. I need 144. I have 144 here, so that means all of this has to be a negative 144 in order for them to cancel out. And I think you can see 1 minus 3 is negative 2, negative 30, negative 66. This is not going to equal negative 144. So is 1 a 0 of this polynomial? No, it's not. Now obviously you're going, Mrs. Trulin, all we have to do is look at this picture down here, and we can see that this is the number 1, and it's not crossing it. Well, yeah. But you know in the regions, you're not going to be really allowed to do that. So is x plus 3 a factor of the polynomial? So in other words, that means you have to do a little thinking here. This is asking you, is negative 3 a root, a 0 of this polynomial? And once again, you're like, Mrs. Trulin, just look down here at this picture you supplied us with. Yeah, negative 3 is a root, but remember, pictures can lie. So to be on the safe side, we're going to do that remainder theorem again. So I'm going to review with you a quick way to do it on your calculator. One way to do it, since you're going to be testing multiple roots, is to take your possible root, which in this case is a negative 3, store it to the x variable, and then you have to press enter. So now it's stored. So the next thing you're going to do is just type in your equation. In this case, our equation was x to the 4th, I forgot it already, plus 3x cubed plus 3x to the 3rd minus 28x squared minus 36x plus 144. Now, every time you typed an x, your calculator thought it was a negative 3 because that's what you stored it as. When I press enter, I hope I get 0. Bingo, I get 0 as an answer. So yes, negative 3 was a factor of this. And again, the graph of p is shown to the right. We're able to look at this, it looks very, very easy, and see that the roots are 2, 1, 2, 3, 4, 1, 2, negative 3, duh, we already know that, 4, 5, 6, and negative 6. So we can look at those roots very quickly and write the equation of this in factored form, because we know it's x minus 2, x minus 4, x plus 3, x plus 6 is the factored form of our lovely polynomial. How else could we have found those factors? We could have divided by this negative 3 once we found it, get ourselves a cubic, factor that cubic, and then get ourselves the 4, 2, and -6. But when a picture will help, we'll take the picture. See ya.